Okay, so we are our last and final section of Unit 1, Section 1.6. These are your notes you should have picked up yesterday. If you did not pick them up yesterday, there are extra copies still in the red basket. So variation of real world problems, meaning that you gotta read. Oh no, we gotta read. It's okay, you'll survive. So first up, variation. So variation functions work as two different types of functions. You have direct variation, which implies that you are multiplying. Okay. So as you can see here, we have k times x. So it's your independent times something. Okay. The k, the constant variable, is found by doing y divided by x. Indirect variation means that you have k divided by x. Your independent is the divisor. Or your k can be found by multiplying x times y. K is what we call our constant of variation. Okay. Every function has a k. All right. Every function has a k. That constant of variation will be there. Okay. First, we're going to look at direct variation. So on your paper, where the blanks are, those are the bold things. So it says for definition 1, that's your first blank, definition 1. We're going to let x and y denote two quantities. When you read y varies directly with x, or y is directly proportional to x, if there is a non-zero number k such that in the box you're putting y equals kx. So when you're reading, the key thing is varies directly or directly proportional to. If you read that in your problem, that means you are multiplying your independent times k. In this situation, the number k is called the constant of proportionality. So as you can look right here, our function is y equals k times x, and we're only focused in quadrant 1. Because we're only focused in quadrant 1, our x's are only going to be greater than or equal to 0. And for the constant variation, your k is going to be greater than 0. So your k is going to be something positive. Are we ready to look at an example?
Yeah.
Okay. So our example we have here is the monthly payment P on a mortgage varies directly with the amount borrowed B. If the monthly payment on a 30-year mortgage is $5.95 for every $1,000 borrowed, find a formula that relates the monthly payment P to the amount borrowed B for a mortgage with these terms. Then find the monthly payment P when the amount borrowed B is $125,000. Okay, so what this is saying, reading from the beginning, the monthly payment P on a mortgage varies directly. That key thing right there lets us know that we are multiplying. Does that make sense? So P varies directly with B. Do we see that?
Wait, hold on. Yeah.
So P varies directly with B. So our equation is P equals K times B. Okay. Then it tells us if the monthly payment on a 30-year mortgage is $5.95 for every 1,000 borrowed. So if your P equals $5.95, then that means your B equaled 1,000. Does that make sense? Okay. So now we're going to keep going. And it says find a formula. So they want us to create a formula to make this possible. Well, in order to create a formula, we need to know what our k value is. Do I have enough information to solve for k? Yeah, I know what P and B are, so I can solve for k. So I'm going to plug in for P. And when I plug in for P, I have 5 and 95 cents equals k plug it in for B, and what do I get? 1,000 times 1,000. What do I need to do to get K by itself? Divide by 1,000. So I divide by 1,000. Are we in agreement so far?
Yeah.
So what is my K value? Someone with a magic calculator? Or I can just move my decimal place over 3. 1, 2, 3.
Yeah, I can see that.
So K equals 595 hundred thousandths. Okay, so now that I have K, I can now say, I got you. I can create a formula. So my formula is P equals 595 hundred thousandths times B. So that was part 1, was creating the formula. Okay, now it asks, what would be the monthly payment if my house costs 125,000? Can I make a prediction on what a monthly payment would be?
Yeah.
Yeah. So it's saying if your B is 125, can you find your P? Yeah. So P would equal times my B, which is 125,000. To calculate that, I just plug it in the calculator. Can someone plug it in the calculator and tell me what you get? So what would be your monthly payment?
Annual. 742.75.
700 what? And 75 cents? So now that I have a formula, what if I had a budget that I wanted to stick to? Like, I don't want to spend more than $1,200 a month on my mortgage. Could I make an estimate of how much I could spend to buy my house? Yeah, so the formula now is set in place that I can calculate whatever I need to calculate for whoever and whomever needs it.
I got a question.
Yes.
I got 2 things. Are you recording?
Mhm.
Okay. My second question is the formula always gonna be P equals KB, or is that just with this?
That's with this specific problem. So every word problem is going to have its own variables and its own specifics. Does that make sense?
Okay.
All right. So we knew that we were multiplying because of what was the keywords for multiplying? Varies directly. This gave us the key that, okay, I'm going to have something times something. Okay. When you're reading, exactly how you read is the order the variables go in. So P was my dependent variable and B was my independent. Okay. My price depended on how much I borrowed. Does that make sense? All right. Questions, comments, concerns? Doable? All right. So that's direct variation.
Yeah.
All right. So then we're going to learn about inverse variation or indirect variation, depending on who you're talking to. So definition 2, we let X and Y denote 2 quantities. Then Y varies inversely with X, or Y is inversely proportional to X. If there is a non-zero constant K such that, and the model here is Y equals K divided by X. So the key thing on your notes, you may want to, this time you're dividing your independent variable. Do we see that? Instead of multiplying the independent, you are dividing, okay? And again, we're still only in quadrant 1, so our x's are positive, but our x's also can't equal 0 in this case, because can you have 0 in the denominator? No, you cannot. So x has to be greater than 0, and k is still positive, okay? See it? All right, let's look at an example. Ready? Ready or not, here we go. All right, so this is an example. Look at the figure right here. You have a two cliffs and you're connecting the cliffs with a bridge to try to walk across. Okay. It says the maximum weight W that can be safely supported by a 2-inch by 4-inch piece of pine varies inversely with its length L. So taking apart what we just read, it says maximum weight varies inversely with the length. Do we see that? So therefore, my setup would be W equals K divided by L. Because it varies inversely. Are we good? All right, experiments indicate the maximum weight that a 10-foot long 2x4 piece of pine can support is 500 pounds. Write a general formula relating the maximum weight to the length. Find the maximum weight W that can be safely supported by a length of 25 feet. So our given information is, it tells us here that we have 10-foot long. So we have a length of 10, and the maximum weight for that is 500. Do I have enough information to solve for my K?
Yes.
Yes. So we're going to plug in and solve for K. So we have 500 equals K divided by
So for the division, is it always gonna be inversely as the
it.
keyword?
Inversely is your
And then-
keyword
Multiplication is always gonna be directly.
directly. Mhm. Okay. I didn't feel like writing anymore. Sorry, I'm just gonna let it show. All right, so what would I do to get K by itself? Multiply by 10. So when I multiply by 10, I get K equals 5,000. They're there. Because I preset it to show the words.
See,
All right. Can I write the formula now?
yeah.
What's my formula?
I don't wanna say, I don't know.
Say it.
X to the I to the X to the R to the A.
Forget her.
5,000 times the R to the Y.
W equals 5
Divided by K.
divided by L.
Oh, my bad, my bad.
Yes.
That's what I did.
K is our 5,000.
Up in there, put one you from.
Did you hear your nonsense?
I don't think it's nonsense. I think it's.
All right. All right. Find out how many feet and how many, what's the weight? If it's 25 feet long, what is the maximum weight that can be crossed? 25 feet long. What is the maximum weight that it can support? Here we go. Okay, so you guys got,
My bad, I got caught up. I got caught up. Shit.
all right. Maddie's mom, Maddie has to go because Maddie decided to sit in class while we're learning. Bye, Miss Stephanie. See you later. I take it off the phone. All right, so you should have got 200 pounds. Did you get 200 pounds?
Yeah.
All right. So if I weigh more than 200, could I walk across that plank safely? No, I would be like dipping. So as you look at the graph right here, the longer the plank gets, the what? No. What's going to happen? The longer the plank gets, the less weight that it's going to be able to hold, right? So the further and further, and that makes sense, right? So think about when you see people walking, they get all wobbly. That's what's happening. All right. Now we're going to keep going. So we're going to talk about what's called joint and combined variation. So with joint variation, what it means is that you have more than one thing being multiplied. So more than one thing is being affected directly. Does that make sense? Okay. So I'm going to read this and I'm going to pause and give you a moment to write what you think it looks like. Got it? All right. It says the loss of heat through a wall. The loss of heat through a wall varies jointly with the area of the wall and the difference between the inside and outside temperatures and varies inversely with the thickness of the wall. Write an equation that relates these quantities. So I give you the variables, and I want you to read it again and write what you think this is saying, okay? Remember, you always have to have a what variable? A K. You always have to have a K. All right. All right. 90 seconds to write what you think. All right, so let's talk about it. It says the loss of heat through a wall varies jointly with the area of the wall and the difference between the inside of the wall. So the takeaway here
I just didn't put K.
is that we knew it varies jointly, tells us that we are what? What based on what it wrote, what is it telling us? That we are multiplying.
But the other one say divide.
Okay. And then the difference between the inside and outside temperatures varies what? Inversely. And what does inversely mean? Divide. So inversely tells us dividing. So looking at our variables, our dependent, so it depended on our L, our heat loss, L, right? And everything automatically has to have a what? A K. The wall varies jointly with the area of the wall and the difference between the inside. Area of the wall is A, the difference is T. So that's A times T. Okay, then varies inversely with the thickness. And what did we say inversely meant? We're dividing. So we're dividing by the thickness, and the thickness is D. Okay. All right.
I'm doing proving.
How do we feel? Do we see
I got it right down.
kind of the words, how they're working together? We've been doing other things. All right, our last part of our notes. The last part of our notes, the force F of the wind on a flat surface positioned at a right angle to the direction of the wind varies jointly with the area of the surface and the square of the speed V of the wind. A wind of 30 miles per hour blowing on a window measuring 4 feet by 5 feet has a force of 150 pounds. Look at the figure below. What is the force on a window measuring 2 feet by 3 feet caused by a wind at 70 miles per hour? Okay. The problem is you guys freak out because there's a lot of words. Thing is, you need to take your time and read through the words and mark the text. If you read through and mark the text, it makes it not as bad. Okay. So beginning, I have the force. So I know that the leading thing is going to be F. Okay. The force of wind on a flat surface positioned to a right angle varies jointly. And what did we just discuss? When something's varying jointly, what does that mean? It has multiple things being multiplied, right? Well, one thing it automatically has to be your what variable? Your K. So K has to be there. And K is being multiplied by the area, which is A, and by the square of the speed, which is V squared. That's what that first sentence led you to, or should lead you to. Okay. A wind of 30 miles per hour blowing on a window measuring by 4 feet by 5 feet has a force of 150 pounds. I'm not just wrote it like that. It's just keep you. It is what it is. I'll go back to not writing. Here we go. Boom. There you go. F equals K times AV squared. Okay. So they give us enough information. So we're going to solve for our K. Because in order to have a formula, you need to know what K is. Does that make sense? So in order to solve for K, it told us here that the window measuring 4 feet by 5 feet has a force of 150 pounds. So using that information, I know my A. I know, and the 30 miles per hour. I know the speed and the force. So I can plug all of those in because it says right here, you have your 30 miles per hour, which is your V. You have your 4 feet by 5 feet, which means the area is, what's 4 times 5? 20. And then you have your force, which is pounds. Wait, because if we remember from physics, Weight is a force, yes? All right. So once you plug that in, now you're gonna calculate your K value. So we're gonna simplify this. I have 150 equals 18,000. I'm gonna divide by 18,000. Your K value, you want it to stay as exact as possible. So you want to keep it as a reduced fraction. So I divide by 18,000. Okay, 15 divided by 1,800 reduces to 1/20th.
Are we done now, Michelle?
Okay, now we have our K. Can we write our formula?
Yep.
What's our formula?
It's 1 over 1. Come on, class, why y'all doing that?
So F equals 1/20th times A times V squared. So the question is, what is the force on a window that measures 2 by 3 with a wind speed of 70 miles per hour? Can you calculate that? I know. What's all right, so when you plug in, you should have gotten 245 pounds. And that concludes our variation, which is the end of our unit. So there will be practice for this on Canvas tomorrow. And the test again has been moved to Tuesday.
The 27th. Yay, another test.